Hello dear students, in this video I'll discuss the questions from Oswaal's self-assessment paper 6 of term 2. Now these are the questions from section A which carries 2 marks each. The first question, the rate of change of sales of a company after an advertisement campaign is represented as f of t is equal to 3000 into e raised to minus 0.3t, where t represents the number of months after the advertisement. Find out the total cumulative sales after 4 months. So here the rate of change of sales of a company, it is given by f of t equal to 3000 into e raised to minus 0.3t. We need to find the total cumulative sales after 4 months. So we have to integrate this function from 0 to 4 to find the total cumulative sales after 4 months. So let f of t be the cumulative sales after t months. Then we have f of t as integral 0 to t small f of t dt. Therefore, cumulative sales after 4 months equal to integral 0 to 4 f of t dt. It is integral 0 to 4 f of t is 3000 into e raised to minus 0.3t dt. So this is 3000 into e raised to minus 0.3t upon minus 0.3 with the limits 0 to 4. Now let us take this cumulative sales after 4 months as capital F of 4. So we have this is equal to minus 3000 upon 0.3 is 10,000 into e raised to minus 0.3 into 4 is, when we substitute the upper limit, we get e raised to minus 1.2 minus e raised to 0. So from this we get minus 10,000 is equal to e raised to minus 1.2 is given as 0.3012 minus e raised to 0 is 1. So it is minus 0.6988, or this is equal to 6,988 units. So the cumulative sales after 4 months is 6,988 units. Moving on to the or part of the same question. Evaluate integral 1 to 3 mod x square minus 2x dx. First let I be the given integral. Integral 1 to 3 mod x square plus 2x minus 2x dx. Now this x square minus 2x, we can write it as x into x minus 2. And if we take this interval 1 to 3, if we take x is positive in this interval 1 to 3, and when we take x minus 2, then x minus 2, if we draw the number line here, 1, 2, 3, x minus 2 is negative in the interval 1 minus 2 and positive in the interval, x minus 2 is negative in the interval 1 to 2 and it is positive in the interval 2 to 3. So here we can use the properties of definite integral and write this as integral 1 to 2 mod x square minus x dx plus integral 2 to 3 mod x square minus 2x dx. Since here 2 is the breaking point for this modulus function. So in this interval 1 to 2, this is negative. X into x minus 2 is negative in this interval. So this is minus integral 1 to 2 x square minus 2x dx plus integral 2 to 3 x square minus 2x dx. Now we can integrate this. This is x cube by 3 minus 2x square by 2 with the limits 1 to 2 plus x cube by 3 minus 2x square by 2 with the limits 2 to 3. Now when we substitute the upper limit, we get 8 by 3 minus 4 minus 1 by 3 plus 1. And now if we substitute the upper limit and the lower limit here, we get here 3 cube by 3 is 27 by 3, which is 9, minus 3 square is 9, minus 8 by 3 plus 4. So here 9 and 9 will go. This is rough. So we have I is equal to minus 7 by 3. Then we have plus 3 minus 8 by 3 plus 4. So this is 7 minus 15 by 3. It is 7 minus 5, which is 2. So the value of the given integral is equal to 2. Moving on to the next question. Find the effective interest rate corresponding to a nominal rate of interest of 8% per year compounded monthly. So we need to find the effective rate corresponding to the nominal rate of 8% per year, which is compounded monthly. So given R is 8% or it is 0.08, the number of conversion periods per year, it is 12 because it is compounded monthly. M is 12. So we have R effective is equal to 1 plus R by M the whole raised to M minus 1. So it is 1 plus 0.08 by 12 the whole raised to 12 minus 1. It is 1 plus 0.08 by 12 is 0.0067 the whole raised to 12 minus 1. Here 1.0067 the whole raised to 12, it is given in the question. It is 1.0834 minus 1 or it is 0.0834. Therefore, R effective is equal to 8.34%. Writing the formula carries 1 mark. Substituting the values, remaining steps, and the final answer carries 1 mark. Moving on to the next question. At what rate of interest will the present value of a perpetuity of rupees 850 payable at the end of each 6 months be rupees 94,000? So here the present value of perpetuity is given and the periodic payments is also given. We need to find the rate of interest. So let us take, let R be the rate of interest per annum. Then we have I is, here we can say it is payable at the end of 6 months. So I is the rate per period, it is R upon 2. And it is given R is 850 periodic payment and the present value of perpetuity is 94,000. We know that the present value of perpetuity, ordinary perpetuity, it is payable at the end of each 6 months. It is given by R by I. So here P is 94,000, R is 850 upon I is R by 2. So from this we get 94,000 is equal to 1,700 upon R. Or we have R is 1,700 upon 94,000. So this when we simplify, we get it as 0.01808. Therefore, R is equal to 1.81%. So the rate of interest is 1.81%. Moving on to the R part of the next question. What sum of money invested now could establish a scholarship of rupees 3,000 which is to be awarded at the end of every year forever if money is worth 7% per annum. So we need to find the present value of the money that we are investing now so that a scholarship can be given for rupees 3,000 at the end of every year. So it is present value of ordinary perpetuity when money is worth 7% per annum. So given R is 3000 and I is 7%. This 0.07. The present value of perpetuity P is given by R upon I. So it is 3000 upon 0.07. Now this when we simplify, we get it as 42,857.14. Therefore, P is equal to rupees 42,857.14. Moving on to the next question. Define secular trend and seasonal variations. Now this is from time series analysis. It is a theory question. Here we have to define secular trend and seasonal variations. This we have studied. The secular trend component is also known as trend series. It is the smooth, regular and long-term variations of the series observed over a long period of time. Say for example, consumer price index. And next we have seasonal component. When a time series captures the periodic variability in the data capturing the regular pattern of variability within 1 year periods, then it is called seasonal component. And the main causes of such fluctuations are climate changes, seasons, customs and habits which people follow at different times. Example can be sale of soft drinks. Sale of soft drinks is usually high in summer and low in winter. Now this pattern is observed every year. Moving on to the next question. Draw the graph of the following LPP. Maximize Z is equal to x1 plus x2 subject to the constraints x1 plus x2 greater than 1, 3x1 plus x2 greater than 3, x1 comma x2 greater than or equal to 0. So here let us take the first one as the first constraint and the second one as the second constraint. So on the graph instead of x and y we have x1 and x2. Let us mark the points. So for the line corresponding to the first constraint is when x1 is 0, x2 is 1. When x2 is 0, x1 is 1. So this is 0 comma 1 and this is 1 comma 0. Line joining these 2 points will give the equation corresponding to the first constraint. So it is x1 plus x2 equal to 1. Then for the second one, when x1 is 0, x2 is 3 and when x2 is 0, x1 is 1. So this is 0 comma 3 and this is 1 comma 0. Line joining these 2 points, it will give 3x1 plus x2 greater than 3. So for the first constraint x1 plus x2 greater than 1, it corresponds to this part. And then for the second constraint 3x1 plus x2 greater than 3 corresponds to this part. The non-negative constraints is the first quadrant. So the region corresponding to all these inequalities, it is this region. Region which is common to all these inequalities is this unbounded region. So this is the graph for this constraints. Moving on to the next question. The demand and supply function of an article are D of Q equal to 1000 minus 0.4 Q square and S of Q is equal to 42 Q. Find the producer's surplus at equilibrium price. So here the demand function and the supply function are given in terms of Q. We need to find the producer's surplus at the equilibrium price. We know that at the equilibrium price the demand curve and the supply curve will intersect. So at the equilibrium point the demand curve and the supply curve will intersect. So we have at the equilibrium point these two are equal. So from that we can find Q and then we can find P. At equilibrium price D of Q equal to S of Q. This implies 1000 minus 0.4 Q square equal to 42 Q. Or from this we have 0.4 Q square plus 42 Q minus 1000 equal to 0. or if we simplify we get q square plus 105q minus 2500 equal to 0. If we divide this whole equation by 0.4 we get this quadratic equation. Now we can solve this equation. If we see 2500, if we take the factors as 125 into 20, so we get 125 into minus 20, then we will get minus 2500. So we can factorize this as q plus 125 into q minus 20 equal to 0. This implies q is equal to 20 or q equal to negative 125. This is not possible. Since negative output is not possible, therefore q naught is 20. Now we can find the price P naught when q naught is 20. Substituting q naught equal to 20 in SQ is equal to 42Q. We get P naught is equal to 42 into 20. It is 840. So for Q naught is 20, that is the equilibrium quantity, the equilibrium price is 840. We need to find the producer surplus at equilibrium price. So the producer surplus, it is given by P naught Q naught minus integral 0 to Q naught supply function dx. So here P naught is 840 into Q naught is 20 minus integral 0 to 20. Supply curve is 42Q dq. So this when we simplify we get 16,800 minus 42 into q square by 2 with the limits 0 to 20. Or it is 16,800 minus 21 into 20 square is 400 minus 0. Or it is 16,800 minus 8,400 which is equal to 8,400 units. Therefore, producer surplus is equal to 8,400 units. So this is the producer surplus at the equilibrium price. Moving on to the next question. Fit a straight line trend on the following data using least squares method. So for various periods, the y value is given. We need to fit a straight line trend for this data using the method of least squares. So first let us draw a table like this. We have for various years 2013, 14, 15, etc. Let us write the y values. It is given as 4, 7, 7, 8, 9, 11, 13, 14 and 17. Now x is here the number of years is 2, 4, 6, 8, 9. It is odd. So we can take x as year minus the year in the middle. The year in the middle it is 2017. So x is equal to year minus 2017. So here we will have minus 4, then minus 3, then minus 2, minus 1, 0, 1, 2, 3, 4. Next we have xy and next x square. Xy we have negative 16, negative 21, negative 14, negative 8, 0, 11, 26, 42 and 68. X square we have 16, 9, 4, 1, 0, 1, 4, 9, 16. Now let us find the summation of all these. The sum of all these summation y, when we add all these we get 90, and then we have xy, summation xy, it is equal to 88, and next we have summation x square. This when we add we get it as 60. Now we can find the straight line trend. Here A is equal to summation y upon n. Summation y is 90 and the number of observations is 9. So A equal to 10. B equal to summation xy upon summation x square. It is 88 upon 60, or it is equal to 1.47. Therefore, the trend line is given by yt is equal to a plus bx. So we found a as 10 and b as 1.47x. So this is the trend line. Moving on to the next question. Compute 5-year moving averages for the following data. So for various years the values are given. Here it is given 2, 4, 6, 8 up to etc. 22. It is easy to find the 5-year moving average. So for various years let us write the values. Let us draw a table like this with year values, 5-yearly moving total and 5-yearly moving average. The values are 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. The 5-yearly moving total is nothing but it is the sum of the first 5 years values. So when we add all these we get 30, and the 5-yearly moving average is this value divided by 5, it is 6. Then we have the next 5-yearly moving total, it is the sum of all this. So it is 10, 20, 30, 40. So this is 40 divided by 5 is 8. And next we have the next 5 years moving total. That is the sum of these 4. All these add up to 50 divided by 5 is 10. And next we have the next 5 years moving total. So all these add up to 60 divided by 5 is 12. Next we have the next 5 years moving total. So it is 10 plus 12 plus 14 plus 16 plus 18. All these add up to 70 divided by 5 is 14. Next we have the next 5 years moving total. 12, 14, 16, 18 and 20. These add up to 18 and the 5 years moving average is by 5. It is 16. And next we have the last 5 years moving total. All these add up to 90 divided by 5 is 18. So these are the 5-year moving total and 5-year moving average. Moving on to the next question. A machine which produces mica insulating washers are used in electric devices is said to turn out washers having a thickness of 10 mils. 1 mil equal to 0.001 inch. A sample of 10 washers has an average thickness of 9.52 mils with a standard deviation of 0.60 mil. Find out T. So here the mean is given, mean mu is given, the mean of the population is 10 mils, and for a sample of 10 washers the mean is 9.52 mils and the standard deviation is 0.6 mils. We need to find T. So given mu is equal to 10 mils, x bar is equal to 9.52 mils, and the sample standard deviation is 0.6 mils. N is 10. We need to find T. Students T statistic. Here they have only asked T, so let us find T alone. Students T statistic T is equal to x bar minus mu upon, here since the sample standard deviation is given, we should have small s upon root of n minus 1, or it is x bar minus mu into root of n minus 1 upon s. Now when we substitute all these values, we will get the value of T. X bar is 9.52, mu is 10 upon s is 0.6 into root of 10 minus 1. So this, when we simplify, we get it as minus 0.48 upon 0.6 into root 9, or it is minus 0.48 upon 0.6 into 3. This is 2.4. Therefore, T is equal to 2.4. This is the value of T. Next question, Rohan invested rupees 25,000 in a corporate bond and the value of investment at the time of redemption was rupees 45,000. If compound annual growth rate for this investment is 7%, calculate the time period for which the amount was invested. Given log 5 is 0.6989, log 9 is 0.9542 and log 1.07 is 0.0294. So here the initial value of investment is given and the ending value of investment is given, compound annual growth rate is given. We need to find the time period for which the amount was invested. So here let us take, let n be the time period for which the amount was invested. So we have the compound annual growth rate as ending value upon starting value, the whole raised to 1 by n minus 1 into 100, where SV is the starting value of investment and EV is the ending value of investment. So given the compound annual growth rate is 7%, then starting value is rupees 25,000 and ending value is rupees 45,000. So this implies 7 is equal to 45,000 upon 25,000 whole raised to 1 by n minus 1 into 100. Or we have 0.07 is equal to 9 by 5 the whole raised to 1 by n minus 1. Or from this we get 1.07 is equal to 9 by 5 the whole raised to 1 by n. If we take log on both sides, we get log 1.07 is 1 by n log of 9 by 5. Now log of a by b is log a minus log b. So log of 9 by 5 is log 9 minus log 5. So from this we have n is equal to log 9 minus log 5 upon log 1.7. So let us substitute all these values. Log 9 is 0.9542 minus log 5 is 0.6989 upon log 1.07 is 0.0294. Or this is equal to 0.2553 upon 0.0294. This when we simplify, we get it as 8.68. Or it is 8 years and 0.68. 0.68 is nothing but 0.68 into 12 months. 0.68 into 12. It is approximately equal to 8.1. So we have n as 8 years and 8 months. Therefore, n is equal to 8 years, 8 months. So here writing the formula carries 1 mark, then substituting the values up to this step carries 1 mark, and then finding the value of n and writing it carries 1 mark. Total of 3 marks for this question. Moving on to the next section, which carries 4 marks each. Section C. A manufacturer produces 2 types of steel trunks. He has 2 machines A and B. The first type of trunk requires 3 hours on machine A and 3 hours on machine B. The second type requires 3 hours on machine A and 2 hours on machine B. Machines A and B can work at most for 18 hours and 15 hours per day respectively. He earns a profit of rupees 30 per trunk on the first type of trunk and rupees 25 per trunk on the second type. Formulate an LPP to find out how many trunks of each type he must make each day to maximize his profit. So here we can see that a manufacturer produces 2 types of steel trunks. Steel trunks are nothing but they are steel boxes which can be locked. And there are 2 machines A and B. So here the first type of trunk, it requires 3 hours on machine A and 3 hours on machine B. So let us draw a table like this so that it will be easy to understand what is given in the question. Next we have the second type which requires, so the second type of trunk requires 3 hours on machine A and 2 hours on machine B. 3 hours on machine A and 2 hours on machine B. It is given machine A and B can work for at most 18 hours and 15 hours per day respectively. So machine A can work for 18 hours and machine B for 15 hours. Next we have the profit per trunk. So on the first type the profit is rupees 30 and on the second type the profit is rupees 25. We need to formulate an LPP to find out the number of trunks of each type that must be made to maximize the profit. So let us take let X trunks of first type and Y trunks of second type be produced per day. So the objective function is given by maximize Z is equal to 30X plus 25Y subject to the constraints. So we have 2 constraints, constraint on machine A and machine B. Machine A can work for a maximum of 18 hours and machine B for 15 hours. So for the constraint on machine A, we have 3x plus 3y less than or equal to 18, and for machine B we have 3x plus 2y less than or equal to 15. So from this we get x plus y less than or equal to 6. So this is the first constraint, this is the second constraint, and then we have the non-negative constraints. So this is the formulation of the given linear programming problem which carries 1.5 marks. Now let us draw the graph. So we have the constraints x plus y less than or equal to 6 and then 3x plus 2y less than or equal to 15. So these are the 2 major constraints. So let us mark the x-axis, y-axis and take the scale as 1 unit as 1 centimeter as 1 unit. Okay. Now let us draw the line corresponding to the first constraint, x plus y equal to 6. So when x is 0, y is 6, and when y is 0, x is 6. So this is 0, 6 and this is 6, 0. Let's draw a line joining these 2 points. We get the first line x plus y equal to 6. Next we have the second one, 3x plus 2y equal to 15. So when x is 0, y is 7.5 and when y is 0, x is 5. So this is 0, 5 and this is 7.5, 0. So if we draw a line joining these 2 points, we get the line 3x plus 2y equal to 15. Now we have x plus y less or equal to 6 means the origin lies in this region. So this is the region corresponding to x plus y less than or equal to 6. Next we have 3x plus 2y less than or equal to 15. It is this part. And next we have the non-negative constraints, which is the first quadrant. So the feasible region is the region which is common to all these. So this is the feasible region. Now let us mark the corner points. Here we can see that the feasible region is closed. So the maximum value of z occurs at one of the corner points. So the corner points are O 0, 0. Next we have P 0, 6. And next we have Q. Here from the graph itself we can see that the coordinates for Q is 3, 3. And next we have R 5, 0. So these are the 4 corner points. Now let us find the value of z at each of these corner points. So we have the origin O 0, 0, next P 0, 6, next Q 3, 3, and then R 5, 0. So at the origin the value of z is 0, and next at P 0, 6 the value of z is 25 into 6, it is 150. And next we have Q. At Q 3, 3, when x is 3, y is 3, the value of z is 90 plus 75, it is 165. Then for R 5, 0, the value of z is again 150. So this is the maximum. So we can see that the maximum value of z occurs at the corner point Q 3, 3, which means the manufacturer should produce 3 trunks of the first type and 3 trunks of the second type to get a maximum profit of rupees 165. So maximum value of z occurs at the corner point Q 3, 3. Thus the manufacturer should manufacture 3 trunks of first type and 3 trunks of second type to get a maximum profit of rupees 165 per day. Moving on to the next question. A textile company has raised funds in the form of 5,000 zero coupon bonds worth rupees 1,100 each. The company wants to set up a sinking fund for repayment of the bonds, which will be after 7 years. Determine the amount of periodic contribution if the annualized rate of interest is 6% and the contribution will be done quarterly. So here a textile company has raised funds in the form of 5,000 zero coupon bonds and the face value of the bond is rupees 1,100. Now these zero coupon bonds are bonds which are sold at a discount. Say if the face value of the bond is 1,100, then they may be sold at 800 or 850 like that, and they will be redeemed at 1,100 rupees at the end of 7 years, and no coupon payments will be made for zero coupon bonds. So that is the use of zero coupon bonds. So here 5,000 zero coupon bonds worth rupees 1,100 each has been sold. So after 7 years they have to settle this much amount, 5,000 into rupees 1,100. We need to find the amount of periodic contribution if the annual rate of interest is 6% and contribution is done quarterly. So let R be the amount of periodic contribution. Then the amount of sinking fund A at any time is given by A is equal to R into 1 plus I the whole raised to n minus 1 upon I, where R is the periodic payment, I is the interest per period, n is the number of payments. So we have A is equal to, so the amount of sinking fund is 5,000 into 1100. So 5000 into 1100. It is 55 followed by 5 zeros. So it is 55 lakhs. And next we have I. I is, here the annualized interest rate is 6%, but contribution is done quarterly. So we have I as 6% upon 4. So it is 0.06 by 4, it is 0.015. Now if we substitute all these, and N is the number of payments done, it is given by 7 into 4, which is 28. So this implies 55 lakhs equal to R into 1 plus 0.015, the whole raised to N is 28 upon 0.015 minus 1. So here 55 lakhs into 0.015, it is 82,500. This is equal to R into 1.015, the whole raised to 28 minus 1. This is equal to R into 1.015, the whole raised to 28 is 1.5172 minus 1. So we get 82,500 is equal to R into 0.5172. So from this we get R as 82,500 upon 0.5172. Now this, when we simplify, we get 1,59,512.76. Therefore, periodic contribution R is equal to rupees 1,59,513. It is approximately equal to. So here writing the formula carries 1 mark, and then finding A, I, N, substituting the values, all these carries 1.5 marks, and the remaining steps and the final answer carries 1.5 marks. So a total of 4 marks for this question. My opinion is we need not be afraid of questions on financial mathematics. Only thing is there are quite a few formulae that has to be remembered. If those formulae are remembered properly, and when we substitute the values, we will get the answer very easily. So no need to be afraid of questions on financial mathematics. They are quite easy. Moving on to the next question. Samiksha borrowed money for new startup from a small finance company and returned it in 5 equal quarterly installments of rupees 7,500 each. What sum had she borrowed if the rate of interest was 12% per annum compounded quarterly? So here it is given Samiksha, she borrowed some amount and she returned it in 5 equal quarterly installments of rupees 7,500 each. So each installment was rupees 7,500 and the number of installments is 5. We need to find the sum she had borrowed if the rate of interest was 12% per annum and it is compounded quarterly. So here given R is equal to rupees 7,500, I is equal to 12% upon 4, which is 0.12 by 4. It is 0.03. So the sum borrowed P, it is nothing but it is the present value of annuity of this R. So sum borrowed P is equal to R into A at an angle N for I rate per period. So it is 7,500, or let me write one more step, R into 1 minus 1 plus I the whole raised to minus n upon I. So if we substitute all these values, we will get the answer. It is 7500 into 1 minus 1 plus 0.03 the whole raised to minus, here n is 5, minus 5 upon 0.03. So 7500 by 0.03 is 2,50,000 into 1 minus 1.03 the whole raised to minus 5. Here I will tell you how we can use log tables to find the value of 1.03 the whole raised to minus 5. So let us take let x is equal to 1.03 the whole raised to minus 5. So if we take log on both sides, we get log x is equal to minus 5 into log 1.03. Now in the log table we can find the value of log 1.03. We have to take 10 and along 3 we have to find the value. So log 1.03 from the log table we will get it as 0.1284. It is 0.0642 minus. Now we have studied in log that we cannot have, here the characteristic can be negative but the mantissa part should not be negative. The value after the decimal point, it should be positive. So what we can do is add and subtract 1. So here we will have minus 1 plus here 1 minus 0.0642. It will be 0.9358. So x will be anti-log of bar 1.9358, or it is anti-log of 0.9358 into 10 raised to minus 1. Now anti-log of 0.9358, it is 8.626 into 10 raised to minus 1, or it is 0.8626. So 1.03 the whole raised to minus 5 is 0.8626. So this is 2,50,000 into 1 minus 0.8626. So the sum borrowed P will be 2,50,000 into 0.1374. So this when we simplify, we get 34,350. Therefore, sum borrowed by Samiksha equal to rupees 34,350. This can be done in the rough. So this is the sum borrowed by Samiksha. Question. Calculate the price of a Reliance corporate bond which has a par value of rupees 1,825 and coupon payment is 7.6% and yield rate is 9.8%. The maturity period of the bond is 3 years. So here the face value of the bond is given. The redemption value is also equal to the face value since nothing is given about the redemption price. The coupon payment, the coupon rate is 7.6% and yield rate is 9.8%. Maturity period is 3 years. So let us write each of these. The face value of the bond F is rupees 1,825. Redemption value C is also rupees 1,825. Nominal rate ID is 7.6%. It is 0.076. The periodic dividend payment R is given by F into ID. So R is equal to 1,825 into 0.076. So this when we simplify, we get 138.7. And the number of periods before redemption, maturity period is 3 years. N is 3. The yield rate I is 9.8% or it is 0.098. Now the purchase price V is given by R into 1 minus 1 plus I the whole raised to minus N upon I plus C into 1 plus I the whole raised to minus N. So here R is 138.7 into 1 minus 1 plus I is 0.098 the whole raised to minus N is 3 upon 0.098 plus 1825 into 1 plus 0.098 the whole raised to minus 3. So 138.7 upon 0.098, it is 1415.3 into 1 minus 1.098 the whole raised to minus 3 plus 1825 into 1.098 the whole raised to minus 3. So let me find the value of 1.098 the whole raised to minus 3 here using log tables. So let us take let x is equal to 1.098 the whole raised to minus 3. So from this we get log x as minus 3 into log 1.098. So log 1.098 is 0.0406 into minus 3 will be minus 0.1218. Here we can add and subtract 1. Minus 1 plus 1. So what happens is we get bar 1 point. Here the characteristic part will be negative. The mantissa part will be 1 minus 0.1218 or it is 0.8782. So x will be anti-log of this bar 1.8782 or it is anti-log of x is equal to anti-log of 0.8782 into 10 raised to minus 1. So this anti-log of 0.8782, the value is 7.554 into 10 raised to minus 1. It is 0.7554. So the value of 1.098 the whole raised to minus 3 is 0.7554. So it is 1415.3 into 1 minus 0.7554 plus 1825 into 0.7554. It is 1415.3 into 0.2446 plus this when we multiply we get 1378.6. Now this when we simplify we get 346.18 plus 1378.6. These two when we add we get 1724.78. Therefore, price of the bond V is equal to rupees 1724.78. So this is the price of the bond. So here writing what is given, finding periodic payment, all these carries 1.5 marks. And then writing the formula, the remaining steps carries 1.5 marks. Writing the final answer carries 1 mark. Moving on to the last question, case study question. Radium, a chemical element, is in the form of radium chloride, was discovered by Marie and Pierre Curie in 1898 from ore mined at Yakimov. They extracted the radium compound from uraninite and published their discovery at the French Academy of Sciences 5 years later. Pure radium is silvery white, but it readily reacts with nitrogen rather than oxygen on exposure to air, forming a black surface layer of radium nitride. It is also known as the alkaline earth metal. So this is the information given regarding radium. Now we have the question. It is given that radium decomposes at a rate proportional to the amount present. Find the particular solution of the differential equation in this scenario. If P% of the original amount of radium disappears in L years, what percentage of it will remain in 2L years? So these two are the questions. We are familiar about the decay model and we know how to find the differential equation and the solution for this differential equation. So first it is given radium decomposes at a rate proportional to the amount present. So let us take, let A naught be the original amount of radium and A be the amount at any time t. So it is given dA by dt is proportional to A, or we have dA by dt is equal to minus Ka. Since it is decomposing, it is a decay model, so we have a negative K here. So from this we have dA by A equal to minus K dt. If we integrate both sides, we get log A is equal to minus Kt plus C, or A is equal, this is log A to the base C, so A is equal to e raised to minus Kt plus C. It is e raised to minus Kt into e raised to C, or we have A is equal to lambda into e raised to minus Kt. We have taken A naught as the original amount. That is, when t equal to 0, A equal to A naught implies A naught is equal to lambda. Therefore, A is equal to A naught into e raised to minus Kt. So this is the first subdivision. Let us mark this as 1. So this is the solution of the differential equation in this scenario. Next we have the second subdivision. If P% of the original amount of radium disappears in L years. So in L years, P percentage disappears. We need to find the percentage that will remain after 2L years. So for the second subdivision, given P percentage disappears in L years. Therefore, at T is equal to L, amount of radium equal to A naught minus P by 100 A naught, or it is A naught into 1 minus P by 100. So in L years, the amount of radium is A naught into 1 minus P by 100. So from 1 we have A naught into 1 minus P by 100 equal to A naught into e raised to minus KL, because it is given in L years the amount of radium is A naught into 1 minus P by 100. So A becomes A naught into 1 minus P by 100 and T becomes L. So from this we can find K. So these two will go. If we take log on both sides, we get log 1 minus P by 100 equal to minus KL, or K is equal to minus 1 by L log of 1 minus P by 100. Now we have to find what percentage of it will remain after 2L years. So for T is equal to 2L, we have A is equal to A naught into e raised to K we have found as minus 1 by L into log of 1 plus P by 100. So it becomes minus into minus plus 1 by L into log of 1 minus P by 100 into T. T is 2L. 2L. Let us take this as 2. So this is from 1 and 2. So this L and this L will go. So we get A naught into e raised to 2 log 1 minus P by 100. Now e raised to 2 log 1 minus P by 100 will be e raised to log 1 minus P by 100 the whole square. E raised to log 1 minus P by 100 the whole square, here E and log will cancel. So we get A naught into 1 minus P by 100 the whole square. So we get A by A naught equal to 1 minus P by 100 the whole square. Now to find the percentage, we have to multiply by 100 into 100. So this is nothing but, so this will be 100 minus P by 100 the whole square, or it is 100 minus P the whole square upon 100 square into 100. So these two will cancel. Now let us write this 100 minus P as 10 into 10 minus P by 10, so that we can cancel this 100. So it will be 100 into 10 minus P by 10 the whole square upon 100. So these 200 will go. As a result, we have A by A naught into 100 as 10 minus P by 10 the whole square. Therefore, required percentage equal to 10 minus P by 10 the whole square percent. So this much percentage will remain after 2L years. I hope this video was useful for you. I wish all the students all the best for your exams. Do well in your exams. Thank you for watching.